to beta training and support online education. This is a question for the 9th standard CBSE Mathematics on the topic lines and angles. This question featured as the first question in the worksheet given to our students, a seemingly hard geometry problem, but turns out to be a fairly easy solution. Let us see the question. This is the problem definition. In the given figure, you will see a figure of a triangle ABC below. AM is perpendicular to BC and AN is the angle bisector of angle BAC. Then the value of angle MAN is. In this triangle, we have been given triangle ABC. Angle ABC, angle B is equal to 65 degrees, and angle C, angle ACB, is given as 55 degrees. And the options are A, 10 degrees, B, 7.5 degrees, C, 15 degrees, and D, 5 degrees. This is a multiple choice question. You have to choose the correct option. Pause the video if you would like to give this problem a try. And when you are ready, we'll continue with the solution. Before that, let us see, before solving this problem, let us look at some of the key concepts used in this problem. First of all, the angle sum property of a triangle. The sum of the angles in any triangle is equal to 180 degrees or two right angles. Then we have the exterior angle theorem of a triangle. If one of the sides of a triangle is produced to a fixed point, then the exterior angle so formed is equal to the sum of the two interior opposite angles. This question is a multiple choice question. The figure for the question has been given in the question itself. Consider the figure. It is better if you would redraw this figure in your notebook as well, so that it is easy for you to follow the steps. We are given the measures of the interior angles of the triangle as angle B is equal to 65 degrees and angle C is equal to 55 degrees. The measure of angle MAN can directly be obtained as angle MAN is equal to 1 by 2, half of angle B minus angle C within the brackets. That is, angle MAN is equal to half of 65 minus 55, which is equal to half of 10. Actually, 55 minus 65 minus 55 is equal to 10 degrees. Half of 10 degrees is 5 degrees. Hence, option D is the correct answer. But the question is, how did we arrive at this solution? We will now present this proof of this solution with explanation. Proof for the solution with explanation is given here. We have reproduced the figure here for your reference. First step, step 1, using angle sum property of a triangle. Since in triangle ABC, angle A plus angle B plus angle C is equal to 180 degrees, we can arrive at angle A is equal to 180 degrees minus 55 minus 65, which is equal to 60 degrees. So our first step is to find out angle A. We have found angle A is equal to 60 degrees. We now move on to the next step. The second step, step 2, using the exterior angle theorem. So here we use the concept of the exterior angle theorem of a triangle. Now AN is the angle bisector of angle A. It is given in the question itself that AN is the angle bisector of angle A. Then we can say that angle CAN is equal to angle BAN, which is equal to half of angle A, half of 60 degrees, that is 30 degrees. In triangle, now let us consider the triangle CAN and use the exterior angle theorem here. Angle ANM or ANB, whatever it is, doesn't matter, is the exterior angle for this triangle CAN, and it is equal to the sum of the interior opposite angles, angle CAN plus angle NCA. So angle ANM is equal to angle CAN plus angle NCA is already angle C itself, which is 55 degrees. So we can write it as angle CAN plus 55 degrees. So angle ANM is equal to 30 degrees, because CAN we have already known that it is 30 degrees plus 55 degrees is equal to 85 degrees. So in this second step, in step 2, we have obtained the angle ANM. Now step 3. Again, now using the angle sum property, or otherwise known as ASP, in triangle ANM, the small triangle over there, in which that angle MAN is included there. It's one of the angles of the triangle ANM. So that is why we take that triangle now. Triangle in this triangle is a right angle that say M, let us say, because AM is perpendicular to BC, it is given. So angle AMN is equal to 90 degrees. Now angle MAN plus angle ANM plus angle AMN is equal to 180 degrees. This is the angle sum property of the triangle ANM. Now we retain angle MAN to the left hand side and bring all the other terms to the right hand side, and we have angle MAN is equal to 180 degrees minus angle ANM is already 90 degrees, angle AMN is 90 degrees, so minus 90 minus again angle ANM, already in step 2 we have found it as 85 degrees. So we directly get 180 minus 90 minus 85 degrees, which is equal to 5 degrees. Actually, what we have done here, substituted the value for angle ANM equal to 85 degrees obtained in step 2. We can go back to step 2 to find out that we have found angle ANM is equal to 85 degrees. Hence, we get the answer as angle AMAN is equal to 5 degrees, which is the required answer, option D. This is a proof for the solution, but actually the solution has been obtained before itself in the as option D. This is a multiple choice question. A general solution for this problem. See, what if the measures of angle the angles B and C were not given in the problem, we have to arrive at the general solution, a general thing. In that case, we have to prove that angle MAN is equal to 1 by 2 of half of angle, that is half of angle B minus angle C, which is another way of framing this question. Another way of asking this question would be prove that angle MAN is equal to half of angle B minus angle C. Now let us consider the figure without the measures. Now the triangle ABC, AM is perpendicular to BC, AN is the angle bisector of angle A. These are the same question, but the angles B and C are not given now. Look at this figure. This is the figure for the general, we will maintain the same figure now. Now, we will use this figure to find the solution for the general case. Thinking skills. How do we find this? Express angle MAN in two different ways by forming two equations with MAN on the left hand side on the LHS. Then we add the two equations and use the angle sum property to simplify the result. Now let us solve this problem by this method. Consider this figure again. Though this figure is not to scale, there is one small assumption here. We have assumed that angle B is greater than angle C, because according to the question, we have AM is perpendicular to BC and AN is the angle bisector of angle A. And it has to be proved that angle MAN is equal to 1 by 2 of angle B minus angle C. So that itself gives us a hint that angle B should be greater than angle C. Step 1. We can express angle MAN two different ways. As first way, angle MAN is equal to angle BAN minus angle BAM. Consider the left side of the figure. Equation number 1. Let us call this as equation number 1. Let's call the right hand side. Go to the right hand side of the figure. Angle MAN again can be expressed as is equal to angle CAM minus angle CAN. You can refer to the figure for a better understanding. Adding 1 and 2, these two equations, this is the second equation. So adding 1 and 2, we get twice angle MAN plus angle MAN gives you twice angle MAN. So 2 times, just like an algebraic equation, we are just adding vertically like that, column wise. Just like that, we are adding 2 times angle MAN is equal to angle BAN minus angle BAM plus angle CAM minus angle CAN. Just we are adding the two equations. But AN is the angle bisector of angle A. Hence, angle BAN is equal to angle CAN. This can be numbered as the fourth equation. Equation number 3. After adding the two equations, we get equation number 3 there. Substituting for angle BAN equal to angle CAN in equation 3. So just we can use angle BAN and angle CAN interchangeably. So we can write BAN everywhere. Instead of CAN, angle CAN, we can write angle BAN itself. So twice angle BAN is equal to angle BAN minus angle BAM plus angle CAM minus angle BAN. So twice angle BAN twice angle MAN is equal to angle CAM minus angle BAM. How did we get that? Angle BAN minus angle BAN gets cancelled out. It just gets cancelled out. So we get the fifth equation, angle twice angle BAN twice angle MAN is equal to angle CAM minus angle BAM. This is the final step of the solution, but it is not uh, ended there. Still we have step to go. Finding angle BAM and angle CAM and substituting in equation 5 obtained in step 1. Now consider the right triangle AMB. This is actually AMB in the left side of the figure. Focus on that. AMB, it's a right triangle. Now consider the right triangle AMB. Using angle sum property, we get angle BAM plus angle ABM plus angle AMB is equal to 180 degrees. Let us see. 180 degrees angle BAM plus angle, we can write angle ABM as angle B itself. So plus 90 degrees because angle AMB is a right angle. So angle AMB is equal to 90 degrees. So let us see that it is equal to 180 degrees. Bring that 90 to the other side, and also we need actually here what we are doing is actually finding out angle BAM and angle CAM. That's all. So what happens here? Will you be able to figure it out? Angle BAM becomes 90 degrees minus angle B. Equation number 6. Similarly, consider the right triangle AMC on the right hand side of the figure. Right half of the figure, you can see that angle AMC and obtain angle CAM as angle CAM is equal to 90 degrees minus angle C itself. That is equation number 7. Now that's it. We now substitute these values of angle BAM and angle CAM. Where do we do that? We do that in equation 5 obtained in step 1. Equation number 5, we have this twice angle MAN is equal to angle CAM plus angle BAM. Isn't it? So twice angle MAN is equal to 90 degrees minus angle C minus of. We purposely introduce a bracket there because there is a minus sign before the angle BAM. So that is 90 minus angle B within brackets. So there you are. Angle twice angle MAN is equal to 90 degrees minus angle C minus 90 degrees plus, here the sign changes when we remove the brackets. There is a minus before the brackets, so the 90 degrees plus angle B becomes, the change of sign is affected there. So we get twice angle MAN, the 90 degrees gets cancelled out. Plus 90 minus 90 minus angle C. So we can shift that angle B to before the angle C. So we can write as twice angle MAN is equal to angle B minus angle C And on dividing both sides by 2, we get angle MAN is equal to half 1 by 2 of angle B minus angle C, which is the required result to be proved. Must be there. We got that proof of that solution. Though it is a big, maybe a long procedure, but it's a simple concept. We are using only the angle sum property in this case. In the second general case, we are using only the angle sum property, and some some manipulation is required. So this forms the thinking skills for a few more questions. A few more questions are yet to come. They follow the same pattern. So keep watching, and this is the required result to be proved. Thank you. Thanks for watching. Please subscribe to our channel to view more videos.